All right, so for what we have right here, we're verifying. Like I said, this is an identity. It is an identity, so therefore this is true. This is valid. This is correct. But we need to make one side look like the other. Okay, we need to make one side look like the other. So we have a cotangent, a sine 2x. So that's a double angle right there, right? And this is going to be 1 plus cosine of 2x. That's a double angle again. Yes?
Yes.
Okay, so I don't like doubles. I do not like them here or there. I do not like them anywhere because it messes up everything. So what we're going to do here is we are going to get rid of the doubles by substituting in for a known answer. So I'm going back to that page with all the different identities. So I'm going to replace sine 2 theta with something. What am I going to replace sine 2 theta with? So let me see. Cotangent x times. Now, sine 2 theta could only be one thing. 2 sine A, cosine A. So those are single A's, right? Those are single A's. So it's going to be 2 sine of x cosine x. Did I lose anyone on any of that? Thank you. Did I lose anyone? All I did is I replaced. Yes, go ahead. Yes?
Is that cosine or cosine?
That's cosine. That's just from that page I just left. So I replaced it with that. Now, I'm going to do the same thing to this side over here, right? 1 plus. Now, I could use any of the cosines because the cosines, how many cosines are there?
3.
There's 3 of them, right? Okay, so I'm going to save this piece here until I get to there, okay? When we did the identities, what do I have to do from this next piece? When I did identities, I don't like speaking trigonometry. We translate it to algebra, right? We don't speak trigonometry, we speak algebra. Now, class, now that these are no longer double angles, I can translate them into x's and y's. Cotangent. What is cotangent translated into x and y's? X over y. Okay? Now, I'm going to put the 2 out front because the 2, it's going to be times all this, right? Okay? Times. Sine. As an identity is y over? 1. Y over 1. Remember, identity. R is always 1. On the unit circle, R is always 1. There we go. So it's going to be y over 1. Cosine. X over 1. Now, what's going to happen here, which is going to make me happy?
The y's cancel out.
Y's cancel. Y's cancel. And so now I'm going to be left with 2x squared, right?
Yeah.
Okay, that's good. 2x squared is going to give me cosine squared, right? 2 times cosine squared, right? Okay, that's going to be my translation. So I need to make sure. Look like you get whooped that shit. Yeah, it's not like this good beat going on. It's like, all right.
What's that called?
Yes, Ninth Roxbury.
Yeah,
All right, so for this right here, cosine of 2x. Cosine of 2x. I told you that there's 3 different ones I could substitute this, right? There was a sine cosine. There is a sine cosine. there is a cosine squared, and then there is a sine squared. If I already know what's on the left-hand side, which one do I want to use? Cosine squared, right? Because the left side was the 2x squared, right? 2x squared. So now I need to not, if I use that one, it's going to make more work. If I use that one, more work. So right here, I'm going to have my cosine squared. So I need to use this one for this case right now. That's the reason why there's a bunch of different ones. You guys have to understand what you have, what you're looking for, and that's going to tell you which one you need to use. Okay, so 2 cosine squared minus 1. So, equals. So that's going to be 2 cosine squared, and this is x minus 1, right? Okay, say yes. Okay, do I have any distribution to happen here? Say no. No, there's no number right here in front of this, right? So if there's no distribution, I have a positive one right here, and I also have a negative one right here, right? A positive and a negative together, those ones are going to go away, aren't they? So I'm left with 2 cosine squared x. Now let's translate it. Let's translate it to algebra. Cosine is always just going to be x, right? So did I verify that this is now 2x squared? So is the left side equal to the right side? Yes, they are. I know this one was kind of complicated because it doesn't give you a direction which to go from the start. So that's why I had to do the left side first, and then figured out where I had to end up, and that helped me with the right-hand side. Because if you do both of them together at the same time, you're like, I don't know. Because the double angle thing is going to be a little bit complicated on the identity. This, oh, not yet. Oh, too soon. Too soon. Yeah, it's already warm in here anyway.
Did you send them the video?
Yeah, I did. They loved it. Okay. All right.
Do you love me?
So,
No.
this is used a lot in upper level math classes. In pre-calculus, if you go to pre-calculus, you guys are going to college next year. Pre-calculus, calculus, calculus 1, calculus 2, all those. This information, okay, you don't need to say that. This is where it's used. This is necessary for those next classes up. All right, so now this says simplify this expression. I forgot to delete the slide. Okay, so I'm going to transfer this over to a new slide. So cosine squared 7x. Okay, so insert page right here. No.
What? Oh my god.
Insert page. So it's, what was that supposed to be?
Cosine
Squared 7x.
7 squared 7x minus sine squared 7x equals 11.
Did it stop? Okay. Okay. There you go. Anyway. Now, it says cosine squared minus sine squared, right? Cosine squared minus sine squared. Does that sound familiar? Does cosine squared minus sine squared sound familiar?
Yes.
So cosine squared minus sine squared sounds real familiar, isn't it? So, what identity, which one am I going to use when I see cosine squared minus sine squared? Cosine of 2x or 2a. But what is my a value here? 7x, right? So it's going to turn into cosine of 2 times my a value in this case is that and that. 7x. So my answer now, using that identity, simplified it all the way down, I'm left with what? Cosine 14x. Cosine 14x is the answer.
Okay, they'll all be like that.
When you just have to pick it out. Identify what it is we're talking about because we've already seen that identity, right? We knew what it was. We even asked what it was. When are we going to use that? Right there. Yeah. See, I slipped him $1 earlier on before class. I'm like, hey, on this question, ask about it, please. Okay. All right.
Can you slip that finger down and make it stop?
I could, but you know what?
Yeah.
Okay, so write this in terms of sine x. In terms of sine x, what type of problem is this right here?
Sine 2a.
That's an addition problem, isn't it? Right, that's when the addition problem. So we had that formula. Remember with the A's and B's, right?
Yes.
A and B, so that's sine of A, cosine of.
Sine, cosine, sine.
Okay, but what's the sign that goes in between?
Plus.
Plus, because it stays the same, right?
Yeah.
Yeah.
And then it's cosine A, sine B. Yes? Okay, so that's what we're going to do. We're going to actually put that together, and we're going to try and isolate this. So let's go ahead and try that. So that's going to give me sine of A. So sine of 2x, right? And then cosine of x plus, that's going to be cosine of 2x, and then sine of x. Okay, I did that right.
Oh, wait. Isn't it cosine?
It's sine A, cosine B, AB, then cosine A, and then sine of B. A and B. This is from last section.
Okay, so I didn't do that.
Okay, so now, every place you see a sine of 2x, what am I going to replace that with?
2y.
2 sine cosine, right? So we're not translating this yet because I can't translate into algebra until it's single angles. They're all single angles. Okay, so this is going to turn into, this piece right here is going to be changed into, so 2 sine x cosine x, right? Times cosine x, right? Yes? Okay, good. So I know that I'm going to need some cosines here, right? So I'm going to need some cosines here, and I got some cosines, but then I have a sine already, so let's take a look. Let's make a sine. Let's use sine instead. Because I'm going to turn all this into sines and see what I get out of it. So look at your identities. Look at your identities. So for sine, this is equal to 1 minus sine squared x times sine x, right? Do I need to go back to that slide? I do not need to go back to that slide, right? I'm good? Okay.
Can that be a 2?
What?
Can that be a 2?
There should be a 2 right here, right?
Yeah.
There should be a 2 here. Okay. Are you on the slide?
Yeah.
Good job. That's why I asked people to make sure that you have the slides so you guys could actually see it.
I'm not
Back
too
in-
lazy to switch to it.
So it's 1 minus 2 sine squared x, right? Right here, this is what I'm doing. 1 minus 2 sine squared. All right, now, do I have any double angles? Say no. I don't have any double angles, do I? I do not have any double angles. I really like it when I don't have double angles. So I translate my trigonometry into in algebra. So this is going to turn into 2y. What's cosine times cosine? X squared. Now, over here, this is going to become, there's a plus sign there, plus 1 minus 2, right here, y squared times y. Is it just too warm in here? Because I see a lot of people zoning off, dozing off. Is it just because it's warm? It has nothing to do with about me being boring, right?
No.
Huh?
I think we just don't want to be here that much.
I know, I'm feeling you right there. Listen. Okay, I'll tell you guys.
It's his birthday.
I really don't want to be there. Okay.
It is?
Yes, today is Dia de Pacho.
Oh, wait,
Okay,
Y'all, we gotta fix
so
this.
I really, and I'm also not feeling very well. I woke up, my throat is killing me. I had to like nag my 6-hour class just to even pick up a pencil. I'm like, ugh. Okay. Yes, yeah. I'm like, come on now. No, seriously, I'll give you extra credit if you pick it up. No, I don't need it. You have a 2%. No, I'm good. Okay. Okay. Listen, you guys. So please, okay. If you guys feeling drowsy, stand up. Okay. Stand up. Walk around a bit. Come back. Continue with these notes. We have to get this done. Yeah. We have to get this done. Okay, you can walk around the back all you want.
I'll walk around home.
Okay, now, right here, from this side, I'm looking at the right side of this. What do I have to do to the right side of this? I have a parentheses with the y attached to that. I have to times it, but I have to distribute, right?
Yeah.
So it's going to be 2yx squared plus y minus 2y cubed.
Well, you just made a cube.
Yes, I did.
Then you add the like terms together, and that.
Do I have any like terms?
No.
No, I don't have any like terms here.
That's the answer.
So my only issue is because it said in what terms?
Sine.
Sine.
And that's still cosine.
Where's my cosine at?
X squared.
That x squared, right? That x squared is the only one that's actually keeping me from being done. So I need all y's, right?
Yeah, why?
Because it said so.
No.
Yeah, see what you did there? Okay. Is there a way I could replace with my x squared?
Yeah, there's a solution.
1 minus y squared, very good. 1 minus y squared. My Pythagorean identity, 1 minus y squared could replace my x squared. Okay, we did that one at the start of this unit. Okay, and we were doing it. So that's the Pythagorean identity. So this is going to be 2y times quantity of 1 minus y squared plus y minus 2y cubed. And again, I have a number outside that parentheses, so I need to distribute. So 2y times 1 is? Okay, 2y times that negative y squared.
Negative 2y squared.
Negative
2y cubed.
2y cubed. Okay, so I did that plus y and minus 2y cubed.
19.
Right? Okay, now do we have like terms?
Yeah.
Yeah.
Yeah. Okay, let's start with how many y's do I have?
Why? Three.
I have 3y, right? Because I have 2 y's right here.
Yes, three.
I have 1 y right here, so I have 3y. No. Right here and right here. These are cubes. Those are cubes, right? So it's got to be the same. So I'm going to have, let's see, I have 3y minus 4y cubed. And so, are there all only y's? So only y's are left, right? So is this satisfy everything is going to be in sign, right?
Yeah, 3 sine minus 4 sine.
Very good. Cubed, right? Don't forget the cube, right? So now, I did all my math in algebra, so now it's time to translate my answer back to trig. So my answer in trig is going to say that this is my 3 sine
3
sine x, right?
minus 4 sine cubed.
There we go. And don't forget, right here, put the little box around it.
Forgot the word after.
A and S, right? Okay, 0 points. Ain't no A and S.
What's your name?
No name and date, upper right hand corner, right?
Yeah, and
Yep, you fell in this
No,
class.
sir, security
It's a
number.
paginate.
What? Paginate?
Yeah.
What's a paginate?
Remember, 4 lines down.
What's paginate?
You gotta do 4 lines down.
Yeah. Like one at how many pages you're using. So if you have 10 pages, that would be page.
Oh,
10.
okay.
And then when you're done, you gotta put a line and then you gotta color it.
Yeah. Color,
Okay,
color.
go color. Put it in sleep.
Are you talking about? Oh.
Okay.
Started.
I love to.
No.
Because you gave me money.
Yep. And she loves you.
All right.
It's easy to bribe. I could
Okay.
be your best friend if I gave you $100.
All right.
You got lunch, but
You ran out.
This is what I'm going to do. I'm going to finish the rest of this tomorrow. Because, you know what? We got through the example we needed to. I wanted to get through more, but I'd rather actually get you guys feeling that you might understand something and give you time to try it. I would like for you guys to actually take out the work right now and try these problems. So when I give you the warm-up tomorrow, and it's going to have the same thing, I'm not going to get an IDK from this. Yes.
I thought I could get all that. I thought I could.
Okay, don't forget, like, share, and subscribe.
Yeah, better.